This is the video notes for Unit 5, Lesson 11H, to market with matrices. In this lesson, we're going to learn about advanced matrices, and it has us continue working with the context of Unit 5, which is working with Carlos and working with Elvira, the manager of the school cafeteria. So Carlos learned about matrices when Elvira, the manager of the school cafeteria, was asked to substitute teach during one of the last days of school before summer vacation. Now that he has worked out a strategy for solving system equations by elimination of variables, that was what was taught in the previous few lessons in Unit 5, he's wondering if matrices can help him keep track of his work. Carlos is reconsidering the following scenario from Shopping for Cats and Dogs, which was, find that lesson really fast. That was lesson lesson 5.8. So he's reconsidering one of the scenarios from lesson 5.8 while trying to record his thinking using matrices. 1 week, Carlos purchased, so this is the scenario, 6 dog leashes and 6 cat brushes for $45 for Clarita while pampering the pets. Later in the summer, he purchased 3 additional dog leashes and 2 cat brushes for $19. What was the price of each item? So he realizes that he can actually represent this scenario using the following matrix. So he can put the value for the leashes in the first column, not the value, but the amount of leashes purchased in the first column, the amount of brushes purchased in the second column, and the totals in the last column. And he can represent the first purchase in the first row and the second purchase in the second row. This right here, putting a system of equations into a matrix, this is called creating a augmented matrix. So this right here is called an augmented matrix, and it represents a system of equations. If you think back to Shopping for Cats and Dogs 5.8, this system of equations looked like this, right? It was 6x, or maybe we used L for leashes, I don't remember, plus 6y equals 45, and then 3x plus 2y equals 19. And that was our system of equations, which he turned into an augmented matrix. Now, typically augmented matrices have the matrix brackets, but they also, right here between the x and y's and the totals, they typically have a vertical line as well. Okay. So he also realizes that he can represent the cost of each item with a matrix that looks like this. So this matrix here is representing the cost of each of the individual items. And it actually has a special name. This is called reduced row echelon form. I think there's no S in there. Let me fix that really fast. Echelon form. Okay, and it has a special look to it. Again, it would most likely have a vertical line right here that divides the items from the totals. Okay, so we're going to learn in this lesson how Carlos went from the augmented matrix to the reduced row echelon form matrix, which shows the solutions, right? 1 leash was $4 and 1 brush was $3.50. Okay. All right, let's show that process. All right. So now he's trying to find a sequence of matrices that fill the gaps between the first matrix and the last. He knows from his previous work with solving systems of equations that he can do any of the following manipulations with equations. He realizes that each of the following manipulations would give him a new row of numbers in a corresponding matrix. So these are really important right here. These three. These are called row operations. Okay. Row operations. So he can replace an equation in the system with a constant multiple of that equation. So let's say he replaced the top row with that same row doubled. That's what that first row operation does. He can replace an equation in the system with the sum or the difference of the two equations. So he can, let's say he can replace the top row with row 1 plus row 2, or row 1 minus row 2, and not change anything, right? It's just a row operation. Or he can replace an equation with the sum of that equation and a multiple of the other. So let's say he replaces the first row with that equation plus 2 times the second equation, or second row, right? So those are all row operations, and I'll show you how to do them. Okay, so we're going to try to go from this, let's get the highlighter, this augmented matrix to this solution matrix, which is reduced row echelon form. Okay, and I'll show you that process. So he thinks that a very good first step would be to go from our augmented matrix right here. And I'm going to put this line that typically shows up. Okay, from this augmented matrix to this second one by multiplying the first row by 1/6. So I think that's actually a really good step. So I'm going to, rather than have this over here on the right, I'm going to have it underneath it, and I'm going to explain like each step that happened as we go along. So the augmented matrix became 1, 1, 7.5, and then the second row didn't change, right? So 3, 2, and then 19. And we have our big brackets around the whole thing and our vertical line. Okay, so I'm going to cross this off here because this is where I'm going to be like writing what happened. Looks like we multiplied row 1 by 1/6. Okay, now that looks more simple. That's good. Remember what the reduced row echelon form looked like. On the left, it had a 1, 0, and then below that was a 0, 1. So we want to try to get this one over here to be a 0. Okay, let's try to do that next. So I think a good way of doing that is to, this is like my strategy that I'm going to use right now, is to multiply row 1 by -3 and add to row 2. So, and I'm replacing row 2. That's my goal right here, to get this blue highlighted one to be a 0. Okay, so we're multiplying row 1 by -3. So row 1 times -3 will be -3, -3, and then -22.5. And then we're going to add that to row 2. So that ends up giving us, for row 1 doesn't change. I'm not doing the change to it. I'm doing the change to row 2. So row 2 ends up turning to 0 and -1 and -3.50. Okay, so that's our new row 2. I don't know if you followed the math there. Let's show multiply row 1 by -3 and add to row 2. So I end up getting -3, -3, 21, 2250, -2250, and then adding it to 3 to 19, right? That's what that description means. And so when I add those, I get a 0 in the bottom left slot. In the one to the right of it, I get a -1, and to the right of that, I get -3.5. Now, I don't really like the negatives, so I think a good second step is going to be to multiply row 2 by -1. That'll just get rid of the negatives. So we end up with no change in the top row yet, but we have 0, 1, and positive 3.5. I'll put my vertical line in. Okay. Oops, I did a mistake. Do you see the mistake that I did? Right here, top left is unchanged. It should just be 1. All right, so now this is looking really good. I actually know the cost of the second item. I know it's $3.50. What was that? That was the cat brush. The cat brush is $3.50 because I have 0 leashes, right? Look at that second row. 0 leashes, 1 cat brush, and then in the totals column, I have $3.50. So I know my second answer, but I have to find my first one. I have to find leashes. So we're going to do one more row operation. We are going to multiply row 2 by -1 and add to row 1. Okay, so we're going to use what we have in row 2, multiply it by -1, and just add it to the top row to get our new top row. So this turns into 1, 0, and then 4, and then 0, 1, and $3.50. And then both of our solutions have shown up, right? So we can say now our solution is 4, $3.50 if we want it as an ordered pair, or if we want to interpret it, like what does it actually mean, we can say a leash is $4, a cat brush is $3.50. Now I'm hoping you're seeing a pattern as I was going about and doing this. The goal each time we do this process, we go from an augmented matrix to the reduced row echelon form, is that we want to get this pattern right here, right? A 1 and a 0, and then a 0 and a 1. That makes it so that we have our solution on the right side in the totals column. This whole process here actually has a name when we use row operations. This is called Gaussian elimination, which is a great name for it, right? Because it uses the ideas that we learned when we were doing elimination earlier in this unit. So this is called Gaussian elimination, this whole process. Okay. All right, let's go ahead and try another one. Okay. It says, find and justify a sequence of matrices that can be used to solve the following scenario. Okay. It says, 1 week, Carlos tried out cheaper brands of cat and dog food. On Monday, he purchased 3 small bags of cat food and 5 small bags of dog food for $22.75. Because he went through the small bags quite quickly, he had to return to the store on Thursday to buy 2 more small bags of cat food and 3 more small bags of dog food, which was $14.25. Okay, so we're just going to start first by showing what this system of equations looks like. So to kind of tie it back into previous lessons, right? So the system would look like this. System of equations. And I'm going to set X to be the cat food. That way we're all consistent. And Y to be the dog food. So if we were using the skills that we just learned in the previous few lessons, the system would be 3x plus 5y equals 22.75. And then the other purchase would be 2x plus 3y equals 14.25. Now we're going to turn that into our augmented matrix because we're going to solve it using row operations. So here's our augmented matrix. So here we have our big brackets. Here's our first column of x values. Here's our second column, which is y values. And I'm going to put the line divider. And then here's our third column with totals, 22.75 and 14.25. Okay, and big close bracket. So this is our augmented matrix. Okay, now we're going to use row operations to solve for the cost of a cat and dog. So we're going to manipulate this augmented matrix using Gaussian elimination to get to that reduced row echelon form. So immediately looking at this, I think a quick way to get a 1 in the upper left box, the upper left slot right here, is to simply subtract, let's see what I have in my notes, subtract row 2 from row 1. I think that honestly is a really good first step. So we're going to say undo, let's put it on the pen, subtract row 2 from row 1. Okay, so we end up with, and I'm just going to cross out this question over here because we need some space to work through the problem, right? So if I do that step, I subtract row 2 from row 1, I end up with a 1 in the upper left corner, then I get a 2, and then $8.50, and my second row is unchanged, right? I didn't do anything to my second row with that row operation. Okay, so this is really good right here. Do you see this? Upper left, I want a 1 there. That was really good. Now my goal is to get a 0 right below it. So in order to do that, I think a good step would be to multiply row 1 by -2 and add to row 2, right? I think that'll be really good. So row 1 doesn't change, right? It's still 1 to 8.50, but row 2, I just did a row operation to it. I multiplied row 1 by -2 and added it back to row 2. So that means I get a 0 here, which is what I wanted. And then I get 2 times -2 is -4, plus 3, -1. 2 times 850 is 17. Sorry, -17, plus 1425 is -2.75. Okay, looking really good. Okay, at this point, don't want negatives, so let's just do a simple row operation. We're going to multiply row 2 by -1. And we already have our answer for y. Do you see that? it's going to be positive $2.75. 0, 1, 275. So one of our answers has shown up. Okay, but we still need to get a 0 where this 2 is located. Do you see this 2 right here? That has to become a 0 for us to know what our solution is to x. Okay, so let's go ahead and do a row operation on that top row. So I think we want to multiply row 2 by -2 and add it to row 1. So we're changing row 1 with this one. So multiply row 2 by -2. So this 1 becomes -2 plus 2. So we end up with a 0 in this spot, which is what we want. The second row is not changing at all with this row operation. And then we're multiplying the 2.75 times -2, which is 550. And we're minusing that from the 850. So we end up with 3. And right there, we have our two answers, right? So our two answers are 3, 2.75 if we needed a order pair, or if we had to interpret it and say what it actually meant, we could say cat food was $3 each, and dog food was $2.75 each. If you remember that from the earlier lesson in the unit, that's what the answers we got. So this is our final answer here. This is our reduced row echelon form that reveals our answer. Okay. So this process that we just did, right, this whole process right here was using row operations. Row operations. That took us from the augmented matrix to the reduced row echelon form that revealed our solutions. Okay. All right, let's go ahead and do our takeaways. All right, how to solve a system using row reduction, right? Row reduction was using those row operations. So this is called, row reduction, again, is called Gaussian elimination. Okay, so let's kind of add in those details, right? Called Gaussian elimination. Okay, the very first thing that you want to do is you want to do row operations to get a 1 in the upper left spot, right? That's like your first priority. Do row operations to get a 1 in upper left spot. Okay. Once you've done that, then the goal is to get a 0 right below it. Okay, so I'm going to write that too. Do row operations to get a 0 below it. Okay, and then just repeat until you get to reduced row echelon form. So I'm going to say repeat row operations until you get to reduced row echelon form, which reveals the answer, right? And just a reminder of what reduced row echelon form looks like. It has a 1, 0, and then the solution. And it has a 0, 1, and your second solution. Typically there's a divider line there. Okay. Let me highlight these and write what they are. Solutions. All right. All right. An augmented matrix includes let me change my color. The first and second columns which have the coefficients of x and y, and the third column which has the totals. And I'll do an example right here so that it's right here in your takeaways. Okay, so example. So let's say I have the system of equations 2x plus 3y equals 24 and 7x minus 4y equals 10. Then the augmented matrix would look like this. The first and second columns have the coefficients of x and y. So it goes 2 and then 3, 7, and negative 4. And then the third column has the totals. So 24 and 10. Okay. All right. I hope that this video helps you on the honors material for Unit 5. Please let us know if you have any questions. I wish you good luck on your practice.